Okay, so this is to go over the first test with you guys, so you have a reference to it. So, looking here, copper hydroxide, if you look at the solubility rules, it turns out this is insoluble. It turns out all alkalis, all nitrates are soluble, so this is soluble. This one's insoluble, this one is soluble, ammonium bromide is soluble, and this one is soluble. So actually 3 of them are soluble. And you do that by looking at the solubility chart. So neodymium here, so the way that you solve this problem is you take these masses and put them with those abundances, so it'll be 0.45 times the first mass to 2.176 plus 0.45, and I'm getting the 40, so this here 45% times 3.1847 plus 0.1 for 10%. Actually, here I'll bring this down here. Plus 0.1 times 24.1934. Whatever that number is, and the answers are at the end of this. So that's how you solve this up. You set this problem up. Now the precipitate here with all these ions, so you have to look to see sodium's is going to be soluble, and so it's not going to, hydroxide or carbonate, it's not going to have a precipitate or a solid. Barium, though, on the other hand, to look at it in the rules, and barium hydroxide is considered to be slightly soluble, but actually barium carbonate is the one with the rules, so this is barium carbonate. So this one here, number 4, you use the old M1V1 equals M2V2. So what volume do we need to make 750? So this is, let's say this volume can be V1. M1 is this, and then M2 and V2, and it's asking for milliliters. So it's really just going to be 275 times 0.0224 divided by 0.0887, whatever that is. So that's the answer, and that's how you figure that one out. So the empirical formula, this is going to be a tough one. So this empirical formula, the way you figure this one out, so it's here, so 2.64 grams of carbon, and then times mole carbon divided by 12.01 for that, or 12. And let me see here. It's not so easy on my screen. I'm going to go back to the original empirical formula. So 0.444 grams hydrogen times mole H divided by 1, and then 3.52 grams oxygen times mole O over 16. So let me grab my calculator out for this. I'm getting my cell phone, so let's see here. So 2.64 divided by 12. This equals 0.22. This is going to be equal 0.44, and 3.52 divided by 16. This is 0.22. Oh, so you divide all by 0.22, and you get, for this answer, then you get CH2O is what you're going to get for that, because you divide all these all these by 0.22, and you get CH2O. Okay. And now, going on for number 6, determine the percent yield that produces 28.65 grams of iron when 50 grams of react with that. So percent yields, this is our actual yield. So that's our actual yield, and we have to figure out what the theoretical yield is going to be. So 50 grams Fe2O3. So unfortunately we do not know, at least we have to figure out what the molecular mass is. So let's see here, mole iron oxide per, and you have to figure out the grams of iron oxide per mole, so we have to look that up. Let me grab my periodic table, and on the side, so it's gonna, so for Fe2O3, it's going to be, I'm gonna do this on the top here, it'll be 2 times 55.85, that's the number for iron, plus 3 times 16, so 16 times 3, that's 48, so then 55.85, and I'm getting those numbers on the bottom of the periodic table. So iron, for instance, if you look at iron, it says 26, and then 55.85 times 2 plus 48, and we get 159.77 there for mole iron. And then let's see here, so there are 2 moles iron per mole of that, so 2 mole iron per mole Fe2O3, and then 55.8 grams iron per mole iron. So if you do this, this all equals, so 50 divided by 159.7 times 2 times 55.85. And I'm missing an 85. 55.85 equals 35 grams. That's 35 grams. And so our actual yield, 28.65 divided by 35. So 28.65 divided by 35. This equals 81.9. So there you go there, D. I'll make sure I'm number 6 is D. 5 is A. Okay, good. Just double checking my answers. So okay, going on. What species is represented by this? 12 protons. The thing that has 12 protons is magnesium. So you know that these things are wrong. So some of those 12 protons is magnesium. It has 10 electrons, so that means it's going to be plus 2. Yeah. I'm fighting my iPad right now. Here. Magnesium plus 2, plus 2. So it's that one. So how many moles of copper oxide can be produced from 9 moles of copper 1 oxide in the following reaction? So here, so if you look here, there is well, it's a 4 to 2 or a 2 to 1. So either way, if you have 0.9 moles of this, you produce twice as many moles of that, so it's going to be A. So 1.8 moles, just because you produce twice as much, right? Because a 2 to 4 ratio. So it's gonna, so yeah, just make twice as much. You start off at 0.9, it's gonna be 1.8. So how many, wait, did I miss one? No, 8, okay. 9, how many grams of oxygen are formed with that? So 6.21 moles, so how many grams of oxygen? So 6.21 mole KOH. And then how many grams? So KOH, and it's a mole O2 to 4 mole KOH, and you get that from these numbers here. And then it's once, and grams of oxygen, 32 grams O2 per mole O2. So it's 6.21 divided by 4 times 32, and calculator is 6.21 divided by 4 times 32, and you get close to 50. 49.7, and right there. So number of protons, neutrons are following, and so it's a neutral species, so it has to be 18. So not this one, not this one. It has to be 18, and well, you can stop here. It's because there's not 40 electrons. The 40 is the protons plus the neutrons, so 22. Answer is D. So I ruled out by the electrons, but the top number, the neutrons, is going to be equal 40 minus 18, which is 22. So that's how you do that one. Balance the equation, number of moles iodine to react with 30 grams of aluminum. So let's see here. So first we're going to balance it. Let's see here, 12, okay. So balance the equation here. So aluminum, there's no aluminums here and 2 over here, so you need 2 aluminums there. Iodine, there's 2 here and there's 6 there, so you need 3 there. So 2 aluminums on this side, 2 aluminum on that side. 6 iodines here, 6 iodines there, so you just leave it. And how many moles of iodine that reacts with 20 grams? Am I reading that right? Let me go back to number 11. Oh, it's 30 grams. So 30 grams of aluminum, so 30 grams aluminum, mole aluminum over, I think it's 27. 27 grams aluminum. And then the number of moles iodine, 3 moles I2 to 2 mole Al. So just wants moles, so then you calculate that. 30 divided by 27 times 3 divided by 2. I'm getting 1.67, and that's B. There you go. Moving on. Density of ethanol is this. How many milliliters of ethanol are produced 15 grams of CO2? So, let's see here. So you start off with 15 grams CO2. So it's density of ethanol. How many milliliters of ethanol? Mole CO2, 44 grams CO2. So then mole, I'm just putting ET for ethanol. I don't feel like writing them out. Mole ethanol, 2 and 2 mole CO2. So ethanol's molecular weight, 2 times 12 for carbon, plus 6 times 1 for hydrogen, plus 1 times 16 for oxygen. So 24 plus 6 is 30. So that is 46. So 46 grams ethanol per mole ethanol. And then how you do the last part, this is milliliter to 0.7, that's a 0.789 grams. So then you put in your calculator, 15 divided by 44 divided by 2 times 46 divided by 0.789. 789 equals 9.93. I get 9.94 is what I'm getting, and it looks so it's quite close to that. Let me make sure I'm not doing something wrong, and 12 is in fact D. So yeah, if you're off by 1 decimal point, it's not the end of the Z world there. So which of the following produce a precipitate? So you have to look at these to figure out is which one's going to be soluble. So all ammonium salts are soluble, all nitrates, and so this is no reaction. Oh, how'd I go backwards? This one's all no reaction. Okay, acetates and nitrates are all soluble. It's not that one. Okay, there actually is an exception for Hg2I2. So this one is going to form one. Sodium, so alkali salts, that's not going to be that. So answer C. C is going to form a mercury iodine precipitate. So how many moles of hydrochloric acid are formed when 50 grams of water reacts in the following equation? So I want molecules HCl. So it's going to be a little so anyway, so 50 grams of water. Let me just do it. 50 grams H2O. Okay, 50 grams, so then mole H2O, 18 grams H2O, and then molecules of HCl are formed, so it's a 3 to 5 mole HCl to 3 moles water, and then the next step is 6.02 times 10 to the 23rd molecules per mole HCl. And so whatever, 50 divided by 18 times 5 divided by 3 times Avogadro's number. That should give you the answer. I'm going to say my calculator will do this real fast. Make sure. So 50 divided by 18 times 5 divided by 3 times 6.02 exponent 23. And I'm getting 2.79 times 10 to the 24th. And that is then A. Let me double check to make sure 14 is in fact A, and that is in fact A. So, see that. 15, sodium azide. Okay, how many moles of nitrogen are produced? So, moles of nitrogen with 2.88 azide. So, Same idea, 2.88 moles NaN3. And then nitrogen 3 and 2 moles NaN3. So 1.5 times that, so you're probably just in your head, whatever 228 plus 1.44 is, whatever the heck that is, right? So 2.88 times 1.5, and my brain's on, so 4.32. It's this one. So that's the way you do that one. More limiting reagents. Okay, nitrogen forms. Okay, limiting reagents and the mass of nitrogen. Oh crap. It's going to be a long one. So let's see here. First of all, let's figure out. So the masses of these. Oh, they already give them. Well, thank God. Oh. That and that. So we're already given that. So that's nitrogen. So 50 from 50 grams of that. So 50 grams N2O4 times mole over 92O2, and then it's like limiting mass of nitrogen, so 3 moles N2, 2 mole N2O4, and the other one is going to be 45 grams N2H4, so mole per 32.05, and then 3 mole N2 to 2 mole hydrazine. So gotta do that. Let's see here. I think it's gonna be the bottom one, but let me just do the numbers just to be sure. Yeah, I'm almost positive it's gonna be the bottom one. So 50 divided by 92.02. Might as well do this anyways. Times 3 is 1.63. 0.63. Actually, no, let's wait, the top one. Oh, wait, the other one's good. Oh, that's right, the top one. Oh, this is going to be the top one. Shoot. But I'm doing the math. 45 divided by 32.05 times 3 divided by 2. 2.1. So, 2.1 moles. So this is the limiting reagent here. So limiting reagent, so we can get rid of that one. So limiting reagent, that there. And this is moles nitrogen. And nitrogen is 28 grams per mole. So 1.63 times 28 grams per mole. So let's see here, 1.63 times 28, it's just 2 times 14, 45.7, I get 45.64, that's close enough. The answer is B, and is 16 is B. Yep. 17, what's the oxidation number of in chromium and potassium chromate? It's plus 6. But how'd you figure that out? It's going to be 0 equals 2 times potassium's oxidation number plus chromium's oxidation number plus 4 times oxygen's oxidation number. And let's put in the number. It's going to be 2 times plus 1 for potassium plus your unknown plus 4 times minus 2 for oxygen, if you follow the chart, and you keep on going and you get chromium equals 6. So chromium is going to be plus 6, also known as hexavalent chromium. How many molecules of sucrose do they have in 143 milliliters? 1 molar. Okay, let's start out with 1.14 moles per liter times how many milliliters we have? 0.0143 liters. If you want to go through and do the milliliters to liters, 14.3 milliliters is 0.0143 liters. And then, so this will give us the moles of sucrose, then times 6.02 times 10 to the 23rd per mole. So that should give us that. So let me do this. 0.14 times 0.0143 times 6.02 exponent 23. And I get 1.21 times 10 to the 21st. So that's B. 18 is in fact B. 19. What is a mass of half a mole of that CFC? So that's C here. So we need to get the molecular mass. So it's going to be 12 for carbon plus 2 times 35.45 for chlorine plus 2 times 19 for fluorine. And I'm getting those numbers on the bottom of the periodic table. So let's figure this out. 35.45 plus 19 plus 19 plus 12. It's 85.45. 85.45. And it's a half a mole. That's divided by 2. 42. So the mass of half a mole of that, CCl2, dichlorofluoromethane. So what is the mass of that? Dichlorofluoro. Am I doing something wrong? Oh wait, I must have done something. Oh, I didn't multiply by 2. That's what I did wrong. This number's wrong. You can see me making mistakes already. 35.45 times 2. 7.9 plus 19 plus 19 plus 12. 120.9, so half of that is this. So 19 is A. So that's what I did. This is 120.9. That's a mistake I made. So, see, people, you make mistakes, just make sure you cover your tracks. Okay, mass of a single fluorine molecule. So, how you solve this one? Fluorine is 19, so 38 grams F2, right, is equal to a mole F2, mole F2, 6.02 times 10 to the 23rd F2 molecules. So it's just 38 divided by Avogadro's number. So 38 divided by 6.02 exponent 23 is going to be 6.31 times 10 to the minus 23, and that's that one. And that's A. So there you go. That's how you do the test. Good luck studying, and I'll talk to you in class.